Welcome to our discussion for the day again. So we're going to discuss another flowchart question so that you can be able to understand how to handle them. So this is a flowchart question still under salts. So we are going to do what we said. We're going to divide it into the respective parts so that you can be able to handle it. Now, so let us look at the starting point. So here, as you can see, we are following the direction of the arrow, the flow of the chart. So we have a mixture K, you add water and you filter to form a solid M and a solution L. So, okay, so this is a hint again. So you have a mixture. In this mixture, so a mixture means you have more than one element or more than one substance there. So you have two things here. Let us say A plus B. You have A plus B, you add water, then you filter to get solution L and solid M. So it means that whatever we are filtering is our solid M. Isn't you here? Now, and then you get a solution. So it means here you are having A plus B to give you two things. To give you a soluble salt, okay, plus an insoluble salt. So this is a method of preparing an insoluble salt, and it is what you call precipitation reaction. So here we know we have a precipitation reaction that is going to occur. Now that is one thing. So we continue. So our solid M, we go to step 2. So the solid M undergoes a step. Step 2, you get a metal oxide plus carbon 4 oxide. Now, carbon 4 oxide is also giving us a hint that the metal, the solid M that is here, it is a solid, or it is a compound that contains, it is a carbonate compound, because where you have the carbon 4 oxide produced, it means that we are thermally decomposing what? A metal carbonate. So here we know that we have a metal carbonate there. So solid M is supposed to be what? A metal carbonate. So remember all these things, you're writing just using a pencil, so that you can be able to finally now come back and write all the equations. So here the hint is that our solid M is a metal carbonate. Now we don't know which metal carbonate it is. So we proceed. We see that you get your metal oxide, and from the metal carbonate, so the step 2, so this step 2 in Amanisha, it is heating. So step 2, it is heating definitely your metal carbonate to give you metal oxide plus carbon 4 oxide. Now you see that this metal oxide, you add nitric acid to it and you form a solution N. Okay, so you have your metal oxide, you react it with an acid to form a solution N. Then it means also this is a method of preparing what? A soluble salt, because this is a solution, meaning this solution N is a soluble salt. Okay, that's why it's going to say it's a solution. So in Amanisha, it is a soluble salt. So that is a hint again. Now, so this is a method of preparing a salt. So we see that this soluble salt of ours, if you had excess sodium hydroxide solution, you form a white precipitate. Okay, so we are going to look at, so if you add excess sodium hydroxide, you're going to form what? A white precipitate. So we are going to look at the salts that, one, form a precipitate when dissolved in excess sodium hydroxide. Also, okay, and also we are going to look at the ions of the salts which form a white precipitate that dissolves when you put them in what? When you add excess ammonium, or in excess ammonia. So let us talk about solubility again of salts. Sawa? So we come and we say, normally we say zinc ions, lead ions, and aluminium ions form a precipitate in few drops of ammonia, okay, in few drops of sodium hydroxide. So here we are saying it can either be zinc, lead, or aluminium. So we have the zinc, lead or aluminium ions present in our solution because they're the only ones which, one, form a precipitate in few drops of sodium hydroxide and dissolves in excess sodium hydroxide solution. So that is why we are saying we have zinc, aluminium and lead ions present here. Now we come again and check what dissolves or which ions are going to dissolve also in excess ammonia. So the ions that dissolve in your ammonia solution, we said in excess ammonia there are only two. The first one is zinc ions, okay, and the other ones are copper 2 ions or copper ions. But copper ions, so here we are saying we either have zinc or copper. Or copper, okay. But now remember the color of copper ions is blue. So if we had copper ions present here, the precipitant won't have been white, but it would have been what? Blue. So we are going to emit copper. So we now know that the substance which forms a white precipitate when dissolved in excess ammonium solution is zinc. So it means also, remember this is one solution, and in one solution you cannot have two cations present. So you only have one cation present. So the positively charged ion. So it means the cation that is present here, it is our zinc ions. Because remember here that only zinc dissolves in excess ammonium solution. So we cut off also the lead there and the aluminium, so we remain with zinc ions present. So this means that the solution N is a solution that contains zinc ions present. So we are going to go back like this, okay? Now, so we know that now solution N contains zinc ion present. But now this solution that you're talking about, remember, now let me come to this side. This solution N that you're talking about, we are saying it is a solution that contains zinc ions, and you found it from, where did you get the solution? You found it from the reaction between a metal oxide that we don't know which it is and nitric acid. Sindio? And then we also said that our metal oxide, we found it from a metal oxide and nitric acid. Then we are going to say that this solution containing zinc ions, then in Amanisha, the metal oxide that was here, what? A zinc oxide. It was an oxide, it was a metal oxide of zinc. Unaona, we've gotten our zinc here, now we are coming back like this. So it means the solution N has zinc ions present, meaning now that our metal oxide that was here was the metal oxide was zinc oxide. So here we write the metal oxide is zinc oxide, like that. Okay, so it means that our solid M here, the solid M, we said it is a metal carbonate. This metal carbonate, you heat it to get your zinc oxide plus carbon 4 oxide. Then it means that the metal carbonate that was here was a metal carbonate of zinc. So it means our solid M was what? This solid M was zinc carbonate. Okay, so that you can have the zinc carbonate, you heat it to get your zinc oxide plus carbon 4 oxide. The carbon 4 oxide is coming because of the carbonate is being emitted because of the carbonate present here. And then from your zinc oxide, you react this metal oxide with your acid. This is an insoluble metal oxide. You react it with your acid to get a soluble salt, which is solution N. And our soluble salt, when you add excess sodium hydroxide in it, you form a white precipitate that dissolves. And we said zinc ions dissolve. The zinc ions dissolve in excess sodium hydroxide solution. And also lead and aluminium. But now we are sticking with zinc because only zinc ions are going to dissolve in excess ammonium solution. Only zinc ions and copper ions, but copper ions are blue, but our precipitate here is white. So we only remain with what? Zinc. So that is how we've come to get this. So umeona, it's like a backward, we are going back like that, right? So we have solved that. Now we go to the second part. We say we deal with one part as we come to this other part. Now we can see our solid M is a zinc carbonate. Now we come to solution L. So we see we have solution L here. So the solution L, if you add excess sodium hydroxide to L and warm it, you form a colorless solution, and you see there is emission of what? Ammonia gas. If there is ammonia gas that is being emitted, then it means that our solution L is an ammonium salt, because that is why you're going to see that there is emission of what? Ammonium gas. And remember that ammonium gas gives what? A pungent smell. So it means our solution L is a salt, and it is a soluble salt of ammonia. Okay, now we need to know that whatever is going to be here, it's supposed to be an ammonium salt. Now we come to this other side. We say that in this solution L, if you add nitric acid and silver nitrate, you form a white precipitate. Okay, so normally we say, when you see silver, I'm coming to this side, so when you see your silver nitrate present anywhere, wherever you're encountering silver nitrate, you need to know that silver nitrate is used to test for halide. Let me light here. Not from, but for. It is used to test for halide ions. Silver nitrate is used to test for halide ions. Halide ions are the ions that are the halogen ions. So halide ions. So in this case, we're talking about chloride ions. We're talking about also bromide ions and iodide ions. So silver nitrate is used to test for halide ions. So we know that here, the solution that we are having here, remember we saw that we had emission of ammonium gas here. So it means the solution is a solution, it's an ammonium salt, and this ammonium salt contains a halide ion. Now we are going to look at the color of precipitates formed when silver nitrate is reacted with this halide ions, if halide ions are present in a solution of silver nitrate. So normally we say chloride ions, if chloride ions are present, they normally form a white precipitate. Bromine, they normally form it's a cream precipitate, it's cream. And iodide ions normally tend to form a pale yellow precipitate. So just from this, we can say that the white precipitate is present because of is formed because of the presence of what? Of our chloride ions. So we can say that our solution is a solution that contains ammonia and chlorine ions. So our solution L is going to be a solution of ammonium chloride. You see the hints? The gas plus the color of precipitate plus silver nitrate. Wherever you're seeing silver nitrate here has given us a hint that we are testing for halides. Okay, so our solution N is going to be ammonium chloride. Okay, and remember, we can confirm this because it is a solution, and we said, so we look at the solubility, and we know ammonium chloride is a soluble salt. So we have found the white precipitate is due to the presence of chloride ions, and so we come back here. So we have filled all the gaps. Now let us come back to this part. So we have identified everything here. Now coming back to our starting point, we said we had a mixture K, and we said that our mixture K was, we said it was our A plus B to give us a soluble salt, and our soluble salt in this case is ammonium chloride. So we are going to write here the product is ammonium chloride and an insoluble salt, which was zinc what? Which was zinc carbonate. So what does this mean? It means that when you form an insoluble salt and a soluble salt, it means that you're reacting to soluble salts. And the two soluble salts that are reacting, we said in precipitation reaction, so whatever is happening here is a precipitation reaction or double decomposition. What happens normally is we have the exchange of what? The exchange of anions, and the anions we say they're the negatively charged ions. So in this case tutakuja tuseme hapa we had our A and our B were formed due to the presence of exchange of our anions. So we are going to write here the equation that is occurring here would be at point K is going to be your zinc, okay, chloride, because we had the exchange of anions. The anions we say that the negatively charged ions. So it was a reaction between zinc chloride and ammonium carbonate. Okay, so it was the reaction between zinc chloride and ammonia carbonate. NH4 ammonia carbonate. Carbonate has a valency of 2, like that. And all these are soluble salts. Okay, so that's why we put the aqueous state symbol. So if you're balancing our equation, we are going to balance by putting a 2 in our ammonium chloride here. Okay, so that is how you handle these equations. So maybe we can write the equation that occurs here at that point. So it is thermal decomposition of your metal carbonate. So it is zinc carbonate. So here you have your zinc carbonate. You heat to form your metal oxide. When you heat zinc carbonate, you form your metal oxide plus carbon for oxide. Okay, so that is the reaction that was occurring there. Do you have another place that you're going to write our reaction? Probably where we're going to have, let me see, where else? Yeah, so we can also have an equation that we can write here. The reaction between now your zinc oxide plus your nitric acid. And we're going to write, so the equation that is supposed to be your zinc oxide, this one, it is solid, plus your nitric acid. We are going to form, this is an insoluble base and an acid. So base and an acid, it's a neutralization reaction, so you form salt and water. So our salt is going to be your zinc nitrate, which is going to be your soluble salt in this case. Okay, so you're going to form zinc nitrate. Let me write zinc nitrate plus water. So you form your zinc nitrate plus, you form your zinc nitrate plus water. Okay, so that is how you write the equation that is supposed to be here. So that is what is going to happen there. Any other place that you're going to write the equation? The reaction between what and what. So that is how you are supposed to handle such a question. First is, we've said you subdivide it into 2 parts or 3 parts, or the many parts that you have depending on the flowchart question that you have. In this case, we've subdivided it into 2. The upper part, this side and this side. We said we are going to be directed by the direction, the flow of the chart, which is the direction of the arrows. So I hope you've understood. Till next time, bye. Enjoy your chemistry and keep learning so that you can be able to handle the respective questions in your test. Till next time, bye.